All right, we're going to do the Bohr model this time, and the Bohr model is the one that's similar to a solar system. And while we now know that's not a perfect model, it is a good way to get the electrons configured and in your brain so you know what's going on. Okay, so fluorine, we're just going to write an F for fluorine because that's its chemical symbol. And then we're going to look at the periodic table and find fluorine. And fluorine is over here at number 9. Remember, 9 means that that's its atomic number and how many protons it has. And its atomic mass is 19, okay? And so that means that there are 10 neutrons, 9 protons. And since we're doing the neutral atom, there is also 9 electrons. Okay. And so now we have to figure out how many rings there are. And well, you can use the periodic table for that. We're in period 2. So that means fluorine is going to have 2 rings or 2 energy levels. I'm calling them rings because remember Bohr is like the solar system. But we've been calling them energy levels or principal quantum numbers, if you remember from the electron configuration. So I have 2 periods. So that means I'm going to have 2 rings. Okay, the first ring has 2 electrons in it. So I'm just going to put them right together. Okay, and then the second ring has 1, 2, 3, 4, 5, 6, 7 electrons in it. And I'm going to put the first 2 together because S is together. And then I'm going to go around for the next 5, up, 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 down, down. It's the same exact way when we are doing the orbital notation. This is the first ring, 1, S2, 2, S2, 2, P, 1, 2, 3, 4, 5. And that's what it is when we look at fluorine on here. Okay. Now that's the neutral atom, but we know when we look at fluorine that fluorine has a -1 charge. Negative, electrons are negative, so that means it has 1 more electron than the neutral atom. So we're going to still draw that first part the same. We have fluorine in the center. And I'm not drawing the protons and neutrons. You don't have to draw them for this unit. Just draw the electrons. 1s2, 2s2, up, up, up. Sorry, make that a little bigger. Down, down. So if you see it, 2, 4, 6, there's 7 electrons, 7 valence electrons, plus 1 more gives me 8 total electrons. So I'm going to add that 8th one in. We had 1 more electron than what we had in the neutral atom. And now we're full. That's the octet rule. Okay? We want to be like a noble gas. What noble gas are we like? We're like neon. We're isoelectronic to neon.